please introduce Raghu Srinivasan and Ramesh Padilla. Thank you.
I'm easy to find.
Thanks, Roger.
Okay. We have been working on this initiative for the last 1 year, so we just wanted to share our story. This way, we have been working on this thing called Kubernetes. We introduced this to Verizon sometime last year, maybe August of last year. We had a discussion with our CIO, and they all approved it. And this has become one of the most successful inner sourcing projects within our organization. We started with a small group of people, maybe 3 or 4 people is what we started with. Now we have around 45 people within Verizon who are contributing, not because they have been asked to do it, they're interested in this technology. So if you are wondering why we are talking about why we titled this as Cavemen to Captains, just wanted to share our story here. As I said, we have been working on this for a year, and we are getting our final security approval today to go to production. And Ramesh and I are here just having fun. So we believe that things are completely automated, so we don't have to be even there to be on these calls. So if everything goes fine, we'll be in production sometime next week. We'll be taking live traffic sometime next week with our MVP applications. Okay, what is this? Come on. Exactly. Do you have one? I did? No, big one. Big one, oh, okay. So it all started in our organization with a simple set of goals. The goal was that we have to accelerate our cloud migration. Okay, it looks very easy. We thought we can just lift and shift it. I'm just joking. Lift and shift, and then everything would be fine. Then it started getting complicated because now we are talking about, while we are doing this, we also want to make sure that we want to modernize and standardize our technology platform. So it is getting complicated because now we are talking about microservices, we are talking about containers, cloud native applications. So how are you going to do all these things? And then they said, we got to do all these things without affecting the developer productivity. So we thought it's time to give up, right? Then we thought, why is it challenging to take an application and move to cloud? Most of the time, at least in our organizations like Verizon, it's a large organization. I mean, we are talking about a global presence. We have developers, thousands of developers working across continents, right? They come with a wide variety of skill set. Okay, we have engineers who are just fresh out of college, and we have developers, architects, maybe 10, 15 years of experience, sometimes even more, right? To top it all, we are a federally regulated company, which means we are more focused on paperwork, okay? So those are the big challenges, and we thought, okay, how are we going to solve these problems? And that's when we started looking at what are the options that we have. Then personally, we all believe that containers could solve some of these problems, okay? And when we look at containers, it would solve some of the application problems, but if you want to make it at scale, work it at scale, then you have to talk about container orchestration. And last year, or maybe 2016, when we started looking at it, there were quite a few options for us. You have Amazon ECS, that's one option, right? You have Mesosphere, DCO, I mean, OpenShift, OpenShift, which is basically Red Hat version of open source Kubernetes, and we have open source Kubernetes on top of it. And at that time, I think if I remember right, even Docker came up with Docker Swarm. So many options. When you have so many options, how are you going to even decide which way to go? What is your orchestration going to be? And that's when we start, okay, let's not focus on which orchestration tool that we are going to pick. Let's look at what we are looking for in an orchestration. So here you see, as I told you that we have been moving towards public cloud. We have been extremely cautious about what we do in public cloud, which means our security posture is that we will not compromise on security posture, whether it is a non-prod environment or prod environment. And then we will not take shortcuts in implementing those security policies. So that's the bedrock of all our decision making, okay? And then comes platform architecture and design. When it comes to platform architecture and design, we wanted to make sure that everything that we do, every choices that we make, adheres to two important philosophy, which is multi-tenancy and multi-cloud. Of course, there is always, when I talk about multi-cloud, we are even talking about, to some extent, on-prem infrastructure, because we have some applications technically that can move to cloud, but for various regulatory reasons, we have to keep it on-prem. So we saw multi-cloud and multi-tenancy was the biggest big requirement for us to move towards cloud. And the third thing is developer experience. As I said earlier, we have developers, a wide variety of developers with different skill set. We just wanted to make sure that anything and everything that we give in this platform should not impede developers' productivity. Not only that, we want to provide a basic set of features on the platform so that they don't have to worry about maintaining them. The platform automatically takes care of them. Okay, so that's where we started with, and then with that we decided that Kubernetes is the way to go. We actually deploy open source Kubernetes. We are on 10.5. That's how it has been very successful in the last year or so with our experiences with Kubernetes. So why we think Kubernetes is important to us. So it all depends on, even before I get into that, let's talk about why am I even talking about Kubernetes and containers in a DevOps conference. So if you look at it, the DevOps is, the principles of DevOps, or at least the most important principles of DevOps is continuous build, continuous integration, continuous delivery. So for anything to be continuous, it has to be automated, right? We have to have and for any process to be automated, we have to make sure that the process that we are automating is consistent and reliable across when it runs on various environments. If you look at containers, containers provide packaging consistency and runtime consistency, right? But when you want to run containers at scale, you have to run it on an orchestration platform, and you want to make sure that the orchestration provides the same level of consistency so that we can effectively manage, for example, access control, which is a big deal for us because we are running multi-tenant platform. We want to make sure that who has access to certain resources, and we don't want application A, for example, to be looking at resources of application B. So access control is a big thing. The next one is, for example, logging infrastructure. Okay. The third one is, I'll say, how you want to monitor your application, how you want to monitor your infrastructure, for example, or how are you going to govern your application? How do you make sure that the application that want to be deployed on a particular namespace is the real application, is the right application that should go into the namespace? So it comes to governance, because governance, again, I told you, we are a regulated industry, so we have to have certain paperwork on what gets deployed where and who has access to those. And the last one is the security. So how do we provide a consistent security posture for our development environment? So when we started looking at these, we said, okay, how are we going to solve these problems? The first thing that we focused on was automating the platform, because that's the first thing that we have to do, because we want our developers to start using the platform. It has to be consistent across all their environments. The first thing that we did was automating our platform deployment. I can proudly say that it takes approximately for us 15 minutes to deploy a cluster. It doesn't matter whether you're talking about a 5-node cluster or a 50-node cluster. It comes with the exact same set of features. So it has the same security posture. It has the same security tools in place. It has the same logging infrastructure, access control. Everything is same. It doesn't matter whether you are deploying your cluster in non-prod dev. It doesn't matter to us. So it's the exact same thing. That's why we are very happy now. Even though we are getting our security approval today, we don't have to be there because we know exactly what we are delivering and what is going to be approved for us, right? The second thing is this. I think this is one of the nicest features, I would say, in Kubernetes. What it provides is what is called customizing the platform, right? It provides 3 levels of customization. I think we are just highlighting three of them. There are a few other things, but we are focused on these 3. The first one is kubectl plugins. If you're not familiar with kubectl, that's the way you access any cluster that is deployed on your infrastructure. What kubectl plugin does is that it helps you customize how you interact with the cluster. And then the second one is what is called custom resource definitions that helps you how to customize the configuration of the resources that are deploying on your cluster. The third one is dynamic admission controller, which helps you customize how you manage the resources that you are deploying on the cluster, right? To go into the details and give some examples, real-life examples, I'm going to invite Ramesh Podilla, who can go into the details of some of these topics.
Thank you, Raghu. Thank you, everyone, and it's a really great event. I'm really glad to be part of this, and thank you for the organizers for this and the volunteers as well. I mean, it's been really a great event to be a part of. Raghu just told you guys about the platform that we built and also the constructs within Kubernetes that make it so flexible. And this is something that we wanted to give to our developer community because a streamlined way to interact with your platform becomes, I think, a very good stepping stone where people don't have to change their mindset going from one tool to another or maybe put in a request in ServiceNow and then wait for things to happen, right? I mean, we want to stay focused within the platform that we're working on. So this is what we wanted to do, and we wanted to highlight with real-world examples as to how the extensibility in Kubernetes helps with some of these things. So I'm going to start off with kubectl plugins, like Raghu just alluded to. And we've used it for doing the SSO and SSO or corporate LDAP as part of every corporate life. I mean, we do have to have a login from a corporate LDAP, and then having integration between the LDAP and then a Kubernetes platform becomes really important to make sure that the authentication and authorizations are done in a consistent manner in a corporate world, right? So we wanted to map these authentication and authorization to the basic constructs within Kubernetes itself, which is the RBAC policies, the role-based access control policies within Kubernetes. That way, we are still following the standard ways that Kubernetes manages its resources, but at the same time give a context to it or a color to it by adding the context of the corporate LDAP in there. And kubectl plugins was really extensible for us, and keeping in theme with anything Kubernetes, you can actually be polyglot in this. You don't have to rely on just PowerShell scripts or shell scripts or Python. We use Python to solve for the SSO part of it, but then you could use anything. You could use a precompiled Go or any kind of script that you are familiar with and then integrate it into this. But then what benefit it provides to our developers is that they don't have to go away from the context of their platform in order to get access to it. And at the same time, it provides a consistent way of interacting with Kubernetes with the inbuilt constructs. The next thing that I wanted to highlight is custom resource definitions. This is my baby, so I'm really proud of this. When I discovered this feature, and we've been playing around with Kubernetes from way back in 2016, but I mean, we've seen this feature come through and grow up from third-party resources to CRDs. But the way this is even though this is a customization, this is a customization on the outer shell of our platform. So we don't really mess around with the internals of the platform where you find that now if you have to upgrade versions or do a patch or anything like that, this is holding you back because you're only putting it as an extensibility feature. And this becomes a very powerful construct to solve a real-world problem like logging. I mean, as we said, we are a very large company. Everybody wants to do logs their own way. And we can't really tell a team who doesn't even have developers on that project anymore to change the way that they're doing logging. We just have to take the way the application is running, and if they want to bring the application to the platform, we have to support their solution. And in order to do that and still stay within the confines of Kubernetes, what we did was we came up with this CRD construct. So what you see at the bottom right there, they can include that as part of their deployment, and that's all they do. They have control on their destiny now. They don't have to open up a service request, wait for some other team to deploy this logging configuration. They can modify it whenever they want, and it acts and feels exactly like a Kubernetes resource, because it is. At the end of the day, this is an extensible component that you've created and you've provided for them. So this is a very, very powerful feature, which I think we're going to use a lot going forward. And we also came up with a framework to make it easy. And just to give a context, I mean, you can do this CRD implementation. There's two parts to it. One is you define the specification as to what goes into the CRD itself, and then there's a controller aspect which implements the logic behind this. And the logic part of it actually is within 100 lines of code for the entire thing that we did in here. And out of that, almost 80 lines of code were, I would say, boilerplate. So we brought out the boilerplate and created a framework out of this, a reusable framework out of this for Verizon, where we can now reuse it for other projects as well that want to leverage CRDs. So this is something that you haven't taken a look at within Kubernetes. I highly encourage you to do so because it stays within the basic constructs of Kubernetes, looks, acts, and feels like a Kubernetes native object. At the same time, it provides you the customization that you need for your platforms. And then the next example that I want to talk about is Ingress and Load Balancer. Ingress is a north-south entry point into your Kubernetes clusters. Usually traditionally done by load balancers, which are deployed on either physical hardware or software load balancers, L4 and L7. We do have to have them. I mean, we do have a layer of L4 load balancers, GSLVs, deployed across regions and all of that. But within the cluster itself, configuring the load balancers through Ingress objects gives you more power and more flexibility with your automation, because right now you're in control of what you want to do within the platform itself as a developer and how you want the traffic to spread without actually raising a request to some other team and waiting for them to fulfill this and so on and so forth. And this is a common theme that we want to solve for, is we want to give the power to the developers so that we're really agile, we're really following the DevOps constructs. And this is where I think doing the L7 load balancing through Ingress objects makes a lot of sense. And now we are also on a journey to make the L4 provisioning as well part of our CRD framework. That way we can evolve it much further, and we can take out the manual touches as part of that as well. And as a developer, you're in control of not only provisioning your load balancer, you can also provide an external alias for it, provide a DNS name for it, create the certificates, and do all of these things at just a deployment spec, a deployment YAML file that you create, a configuration file. Lastly, I want to talk about admission controllers. There are two types of admission controllers. Admission controllers are gatekeepers for any deployment configurations that are coming in. We're all familiar with labels concept within EC2. Right, so or AWS. We do that for a lot of reasons, and then we actually bake them into the processes and as part of our corporate to use them for maybe saying which line of business a certain deployment belongs to or a certain artifact belongs to in our cloud. We want to provide the same kind of construct within Kubernetes platform as well. So what we ended up doing is we wrote our own admission controllers to enforce this policy. So this is a validating type of admission controller that tells the developer right then and there that they have to provide certain labels and then declare what line of business a particular deployment belongs to. Also ensure that they have to have a CPU request as part of this, so that way they're not eating up the whole resource of the platform. They're limited to a certain CPU requests and certain memory limits and such. There's another type of admission controller as well called a mutating admission controller. Yesterday, our colleague Mohammed Bayan was talking about Istio as a service mesh provider. They leverage that. What it does is it provides you a way to inject some sort of dependencies during your deployment time. Now, you can use it for your governance process to say, this is the standards as a corporate I want to follow, and this provides you a way to enforce those kind of standards. So there's mutating and validating admission controllers that you can take advantage of within your platform itself. Moving on, though, I mean, David gave a really great presentation on security, and we want to make sure that we always have this in the back of our minds. When we are talking about any platform that we build, it's from day one that we engage with our CISO organization. They were partners for actually bringing this platform along. We didn't have tools within the organization that could support this technology to begin with. So we partnered with them as to do POCs and do a lot of proof of technology with different vendors, software vendors, and also the constructs within Kubernetes itself as to what makes sense, what is the security guidelines that we have to follow for containers, for Kubernetes, and all of these other things that we bring onto the platform. For example, the certificates that are managed as secrets within the platform, or passwords and things like that. And how do we make sure that only the containers that are talking to each other, they're allowed to talk, and there's nothing else that is happening which can say that there's something wrong happening within the cluster. So for all of these things, I mean, from day one, we wanted to ensure that we have a solution for this, working with our CISO partners, and we brought on the right tools and integrated them from the point that somebody develops a new container image. So we make sure that even before pulling it into the image repositories, we scan them. We have an automation pipeline to scan it and let the developers know upfront that if there are any vulnerabilities to fix it. So there's static scanning available that way, and then there's also the runtime for the platform itself is scanned all the time, and it's monitored all the time. So there's different levels of monitoring. There's log monitoring, network monitoring, and then there's the security monitoring that takes place as well, because what's secure today may not be secure tomorrow. So we want to ensure that if there is a new vulnerability that exists based on what is running, based on the workloads that are running, we patch those gaps, and we alert people, and we can take action on them as well, not just passively letting some team know that there's some vulnerability. If it's a critical enough vulnerability, we can shut it down and or reroute the traffic somewhere else. So with all of these things, I wanted to bring this back into the context of how this has helped us along our journey in the cloud adoption. And for that, I'll bring Raghu back. Thank you.
Thanks, Ramesh. So one of the things that I want to highlight with regards to the security is that if you are interested in using Docker or Kubernetes, make sure that you follow the CA's benchmark. You can get CA's benchmark for Kubernetes and Docker. I think we follow it, because if you start doing it, you can really make your security team happy. Okay, and also another one that I wanted to highlight, what he was talking about, the pipeline, the code pipeline. We do the exact same process even for managing resources that are managing the images that we download from Docker Hub. We don't go let developers go download whatever they want. We have a streamlined process of how you pull images from there. It's completely automated, by the way. It's how you get images from there. We do the scanning. We do the exact same scanning that we do for every application. And if there are problems, we go fix them, and before we let those things into our platform. That said, in conclusion, as you know, we as a team, the people who started this, I mean, as a team, we really believed, and we still believe that Kubernetes, containers with Kubernetes will solve some of the migration challenges that you have. And because if you automate well, if you automate your platform really well, then most of the challenges that a developer normally faces in a typical migration can be easily solved. I'll just give you one example. One of the things that all our developers face is that when we move our application towards AWS, one of the challenges they always had was AMI rehydration. With this platform, the developer need not have to worry about anything about rehydration, because the platform takes care of it automatically. We have every 30 days, we have new image that pops up that we need to update, and we do that effortlessly these days. You just click a button and you get the new image, run it through all your instances, and the developer does not even know that we have updated the underlying OS. So that's easy it is. And I just wanted to share one more tidbit here. It's basically, when we started this application, we started with two MVP applications. One of them were able to save at least, I think, 60 to 70%. They were able to reduce costs 60, 70% by moving to containers platform when compared to the same kind of setup on an on-prem infrastructure. So you do it well. We believe that this will change the way you do migration do public cloud migration. Thank you very much. And one more thing, if any one of you is interested in sharing your experiences, and if you have better ideas, we would like to hear from you. We can talk it in open spaces, or you can even email us. We would like to really hear from you. If there are any interesting ideas, we would like to collaborate with you as well. Thank you very much.
Thank you.
All right, thanks Ramesh, thanks Raghu. A couple of service announcements. We have snacks outside, so for those of you who are interested, we're going to cut to break here in just a minute. There are snacks outside, so please avail yourself of those snacks and enjoy. There is coffee downstairs, so if you're needing a quick pick-me-up or some caffeine, directly downstairs in the foyer. And with that, we're going to move to break. Please come back in 10 minutes. Thank you very much.